When solving an optimization problem, there's 5 steps you're going to want to follow. First, identify all given and to be determined quantities and draw a sketch of the problem. Then, write the primary equation for the quantity that will be maximized or minimized. Third, reduce the primary equation to have a single variable, and you may have to use secondary equations, such as length is equal to twice the width. Fourth, determine the domain or the possible solutions for your problem. And then 5, using calculus techniques, find the values for the optimized variables. So for example, a farmer has 2,400 feet of fencing and wants to fence off a rectangular field along a straight river. What dimensions will give the largest area? So first, we want to identify our given variables. So we were given that he has a total of 2,400 feet of fencing, which is the perimeter, and we know that he's along a river, so one side will have no fencing. And we'll draw our picture out over here. And label each of our sides. We'll label the widths X and the length as Y. So, we also know that the perimeter of a rectangle is 2L plus 2W, but since there's only one side, we can change that to L plus 2W. So that is our given variables, and we are going to want to write the primary equation that will be the one being optimized, which is area in this case, and we're maximizing it. So you'll know that area is equal to length times width, which is in this case X times Y. So now that we've done our second step, which was write primary and secondary equations, we can simplify the primary equation to only have one variable by using the secondary equation. So we know that perimeter was 2,400, so we can change this to equal 2,400 is equal to y plus 2x, and the easiest possible variable to simplify would be y, so we can find that y is equal to 2,400 minus 2x. And we want to take this and plug it into our equation to be optimized. So now we have that area is equal to x times 2,400 minus 2x, and that completes the third step of optimization, which is simplifying the primary equation to one variable. Now we are doing the fourth step of optimization, which is finding the domain of the problem. And to do that, we take our equation and we set it equal to 0. So we know that x will come out, and so 0 is one of the answers, and then we solve for x here. So we know our domain is anywhere between 0 and 1,200. Now we will do the calculus portion. So we take our equation, which is area is equal to x times 2,400 minus 2x, and you multiply it out. So that comes out to 2,400x minus 2x squared. And then you take the derivative of this. So you get a prime is equal to 2,400 minus 4x. And to maximize this, you set this equal to 0. So then you get negative 4x is equal to negative 2,400. So x is equal to 600. So we know that x is equal to 600. You can take that and plug it into the equation y equals 2,400 minus 2x, which was the equation for perimeter. And when you do that, you get y is equal to 2,400 minus 1,200. So y is equal to 1,200 feet. And since the question asks for the dimensions of the fence, your answer would be 600 feet by 1,200 feet. And that is all.